Hello.
Thank you,
Hello,
Tom. Yes, fantastic. So it's just about time to start. Let me stop the screen share on my side. And it's time. So our next speakers are Andreas Papasalouros and Antonis Tsolomitis from the University of the Aegean in Greece. They're both professors of mathematics. The University of the Aegean is located on the island of Samos, the birthplace of Pythagoras. Andreas is an expert in educational software, and Antonis is a mathematician, very experienced in tech. And I leave the floor to you.
So, may I start?
Yes, absolutely.
Yeah, thank you. I hope that you can see my presentation now.
Yes, it's okay.
Hello from Greece. Thank you, Arthur, for the introduction. I'm going to present together with Antonis a tool, a software tool named LaTeX2nemeth, which is a direct LaTeX-to-Braille transcribing tool. Now, the outline of this presentation has as follows. First, I will give the motivation and the aims of this project, of this tool. Next, I will give some background on the Braille and the Nemeth codes, which are ways for representing textual information for the blind and the visually impaired. As the name of the tool suggests, its aim is to transcribe from LaTeX documents to modes of representation of textual representation that that can be read by blind people. I will give the characteristics of this tool, and some details about the implementation and some special features. And we will conclude with an evaluation, with a presentation, a brief presentation of an evaluation, and some conclusions. Now, the motivation for this project, since none of us, neither Antonis nor I, are experts in accessibility, in issues about accessible software, the motivation for this project has as follows. Back in 2014, we came to know about a visually impaired student of mathematics at the University of the Aegean, of Athens, excuse me. She was not studying in our university, but some colleagues there in Athens pointed out to us this student who was the first student of mathematics in Greece for, I think, 30 years or so. So this student could read and write in the Braille notation and in Nemeth representation of mathematics. I will give in some slides some more information about both Braille and Nemeth. And the problem was that although textual notes and course textbooks were available, of course, in LaTeX source format, the professors, her professors, had their books and their notes in LaTeX source format. There was no reliable way to transcribe these sources into appropriate representations so that she could read them easily. So because of this, this student had to manually transcribe learning material with the help of a seeing person, which was a very painful process, as she has described it to us. So we set out to create a tool for transcribing these LaTeX sources into Braille and into Nemeth, so as to be accessible for her. Actually, this particular case, we happen to know afterwards, after beginning to study this problem in more depth. We found that this is a wider problem, and visually impaired students of mathematics or related fields did not have a proper access to the bulk of study material available in LaTeX format. The Braille code, I think that we all know some things about it, allows the tactile representation of characters in various alphabets, giving access to reading text to visually impaired persons or blind persons. The 6-dot system, the 6-dot Braille system, supports 64 different characters, because each character is depicted in is represented as 6 dots meaning that there is either a presence or an absence of a dot in each character of this set of symbols. So an assignment of Braille symbols to letters, that is an encoding, defines a certain Braille alphabet, for example, English, Greek, German, Hebrew, Russian, etc. We understand that these encodings can be quite complicated, because this character set has only 64 characters, and typically we have to represent many more characters than this particular limited number. So this is a rather familiar picture of a person who reads these tactile representations of a Braille text. We see that we have linear arrangements of these characters, and with this tactile form, the person who is acquainted with this language can read texts, or as well as music, mathematics, and other forms of information. The Braille text, the sequences of 6-dot characters, can be represented as a plain text files, which contain this representation of these characters. And we have specialized printers, embossers, which can print these text documents in appropriate media, so as to be accessible and readable by blind and visually impaired persons. This is an example of such an embosser. The Nemeth code is specialization of the Nemeth of the Braille system, aiming for representing the mathematics symbols and mathematics texts. This code defines sets of rules that designate the combinations of Braille symbols that describe the various types of mathematical symbols and of mathematical structures. So it does not only represent symbols, but also it can represent the structure, the syntax of complicated mathematical expressions. The original document of Abraham Nemeth, a blind mathematician that invented this system, specifies 25 rather extensive rules, which rules cover various aspects of mathematical structures, such as numeric signs and symbols, alphabets, various alphabets. For example, in mathematics text, we can have, for example, Latin, but also we can have Greek or other characters and symbols. All of these must be represented within this set of just 64 Braille symbols. Fractions, superscripts and subscripts, radicals, symbols of groupings of various symbols, spatial arrangements. For example, we can represent a matrix or other expressions that have specific layouts in horizontal and vertical meanings, etc. The document itself, the original document of the Nemeth code, can be found here. The aims of this project, of LaTeX-to-nemeth project, were first the reliable transcriptions of books and electronic notes from LaTeX to Nemeth and Braille. It is important to stress the reliability of the process. Mathematics is a subject of great precision, and texts that contain even minor mistakes are very difficult to comprehend or even impossible to comprehend. So the whole process must be accurate enough in order to support the process of the study of mathematics by blind students. A second aim, which came at the second step, I might say, is the creation of a repository of mathematical texts available to visually impaired students, researchers, and other interest parties. At least at the beginning of this project, at the end of 2014, and to the best of our knowledge, no tool or method or combination of tools could meet the above requirements, especially the first requirement, the reliable transcription of books and notes. Some commercial solutions existed. Actually, there were some solutions at the time, and first some commercial solutions. The conversion from LaTeX to Word with MiKTeX, and then the use of other specialized software such as the Duxbury software, which could translate the Word representation, the MiKTeX representation of mathematics and text into Braille and Nemeth. Many mistakes were created during this process in the extensive experiments that we did at the time. Second line of the second method using open source solutions was based on LibLouis, the LibLouis tool, which could transcribe MathML representations into Braille and Nemeth. So we could generate MathML representations from text using tools such as the Text for HD tool, and then as a second step, we could generate Braille and Nemeth representation from the MathML, which is an intermediate representational format. This process, unfortunately, also at the time produced many mistakes, and so we set out, as I said, to generate a solution that is a direct one. That is, we directly generate Braille and Nemeth texts from text. The features of this tool, of our tool, which we created from scratch actually, We support LaTeX files in Greek, English, also ancient Greek, and converted them to Braille and Nemeth where appropriate. More than 850 different mathematical symbols are supported. Also, almost all TEG AMS mathematical symbols are covered. And also different Braille alphabets can be supported by using different encodings, different symbol tables, as we say. For example, one can create their own table, their own table of which define the Braille symbol for each character in Russian, in Hebrew, and other languages, and so extend the tool with the ability to generate texts in other Braille alphabets as well. The flow of translation, the usage of the tool, is illustrated in this slide, in this picture. We have the source text files, one or more text files, and we first feed the text files to LaTeX in order to generate the auxiliary files. These files are mandatory and are used in the process of generating the Nemeth and Braille texts. Also, optionally, we can use an additional symbol table, which is a JSON file, which contains the definition of the new characters in other languages, other than the ones that we currently support, in order to generate the text. The output of the process is the Braille and Nemeth or Nemeth files in their text format. Also, there is some limited, I have to say, support for the generation of images in PDF format. The texts are fed into a text parser, like the one that I depicted previously, and the images are printed in appropriate and specialized graphics imposters, so as to produce some tactile graphics and be read by blind and visually impaired persons. Let me start from clarifying a bit what is the process for the images. Here we have an image, actually a PS-Trick image. Only PS-Tricks is supported, and we have a simple filter that reads the labels of the images that contain mathematics, and uses the transcription mechanism in order to produce Braille text for these mathematical labels. So if we have this PS-Tricks code that generates this picture here on the left, the program filters out this O and this R or other symbols or mathematical expression, and substitutes it with their Braille correspondence. The transcriber is based on a parser which is created from scratch. This parser recognizes most of the common LaTeX commands and environments, and also mathematical symbols. It is developed in Java. We have used the specialized tool, the Java compiler, Java CC, for the lexical and analyzer and the parser and the syntactical analyzer. And the software itself is a Java archive, a jar package, which can be run in a system that has a Java runtime environment. Here we have some details about the process of the implementation, which are not very important right now. I would like to say some things about the parsing of mathematical expressions, which is of more importance, I think. The mathematical expressions are parsed into appropriate syntactic trees in memory. So we follow a traditional parsing process, which as it is found in compiler systems, and we generate abstract tree representations, abstract tree data structures in memory for each mathematical expression. These abstract trees, these data structures are then translated into appropriate Nemeth code by using specialized semantic routines. For example, for fractions, for superscript, subscript, for the roots, etc. We have for each kind of these expressions, we have a specialized routine which runs and generates the appropriate Nemeth code. These data structures follow an object-oriented logic, and especially in particular the composite and interpreter design patterns, which are very well-known techniques for object-oriented design. And here we see that we have an expression, and an expression is an abstract class. We have some subclasses, some concrete subclasses, the fraction, the superscript, the subscript, and other mathematical expressions. So this generates a kind of a recursive data structure, which can be visited in appropriate ways, so as to generate the Nemeth code. Here we have a sample expression. We have this expression which demonstrates the well-known fact that mathematical expressions can be nested and have an arbitrary depth of nesting. So here we have an exponent which has another exponent, or a complex fraction which has another fraction inside. This expression is rendered in Nemeth as follows. Here we do not depict the actual 6-dot symbols because it's very hard to follow. And we see here that we have this expression, which is represented in this way. So here we see that we have an x, which is an indicator of an exponent, and here we have an x2, which is an indicator that we have a second exponent inside the first one. This formalism is a rule defined by Nemeth in order to help a blind person to mentally, to cognitively reconstruct the depth of the structure of each expression, given that they cannot see this expression in the first place. So there is an indicator that we have an exponent, and there's a second indicator which is different from the first, that we have an exponent within an exponent. So we see here that the process of the generation of the Nemeth code is context sensitive, and the data structures that I presented before helps us generate and support this context sensitive generation. And analogous situation we have here with the fraction. So we have an open fraction indicator which represents this fraction. And here we have a second fraction, and here we have a second open fraction indicator. We can see here that the indicator of the depth of these structures is different for the exponent and for the fraction. For the exponent, we have an indication of depth 2 in the inner expression, while for the fraction, we have an indication of depth 2 for the outer expression. All these details are handled by the software. As I said before, these indicators are nothing but appropriate symbols, Braille symbols, or combinations of Braille symbols. For example, for the single exponent, the symbol is this one, but for the double exponent, the symbol is this one. It's 2 of the goal. We have appropriate methods for the objects of the expression class that, as one might imagine, visit the abstract, the syntax trees, the syntactic structures, either top down or bottom up. For example, for complex fraction, the process is calculated bottom up with this method, while for exponents or superscripts, subscripts, roots, etc., the process is top down, and the method, the appropriate method, is assign other levels method. Also, the Nemeth language supports what is called special arrangements. That is specially aligned structures, such as arrays, cases, aligned expressions in mathematics, etc. So here we have a simple example of an array that defines this situation, and the appropriate and the corresponding Nemeth code is this one. Maybe it's not very clear what's going on, but here we have a linear arrangement which represents this kind of expression, and then we have a spatial arrangement which aligns this structure both in this and in this direction. So here, for example, we have these expressions which are aligned, the one on top or on top of the other, or beyond the other. These kind of situations can be found, of course, in arrays or in matrices and other mathematical structures, and it is supported by our tool. Although the Nemeth code is quite extensive, there are symbols in modern mathematics, for example, in the AMS tech mathematics, that are not supported by Nemeth, are not found in the Nemeth code. So we have proposed some new Braille symbols. In this process, we have used the mechanisms that are suggested by the Nemeth rules themselves. For example, in the Nemeth code, we may find this symbol, which is recognized as an arrow, as a right arrow, but we cannot find this symbol, the hook right arrow, which is I understand that it is used in analysis, mathematical analysis. So we proposed an extension of the standard Nemeth right arrow symbol, giving this expression. this sequence of symbols. This is generated as follows. This character signifies the grouping of characters in a new symbol in the Nemeth sense. And we combine this grouping indicator with the existing arrow symbol and with this sequence, which signifies the characteristic hook in the above hook right arrow symbol. In this way, we have proposed a list of new symbols, new Braille symbols that are not, as I said, available in the original Nemeth list of symbols. Also, the program has support for the ancient Greek alphabet. It is, I would say that this is a demonstration of the extensibility feature of the system, which can support different alphabets that modern English and basic Latin and English, and modern Greek and English. Here we see how the first verses of Homer's Odyssey is transcribed into Nemeth. Sorry, into Braille code. No Nemeth. There are no mathematics here, so it is a Braille alphabet for ancient Greek. The documentation of the system. The documentation is available at the site, at the website. There are several documents. We have a dictionary of mathematical terms from symbol to Nemeth, from LaTeX-to-nemeth, and also you have a reverse dictionary of mathematical terms from Nemeth to LaTeX. And also, these dictionaries are available for both seeing and the blind persons. That is, there is a representation like the one that I showed before, but also there is a fully Braille Nemeth representation of these dictionaries. Also, we have the following scientific papers at the one article at the Journal of Science Education for Children with Disabilities, and a short article in the ICM SIG Access conference. The distribution of the system, the web page is this one. The system is available at the CLAN repository, and its source code is available at the source codes. The tool also is available in major LaTeX distributions, texlive, MiKTeX, and MiKTeX distribution. But it works in Linux and Windows. About the repository, we are constantly creating a repository of publicly available mathematical and scientific content in Braille and Nemeth. So far, there is one book in English, at least 12 books and course notes in Greek, and one book in ancient mathematics, Homer's Odyssey. As I said before, all books are also available at the web page. The evaluation of the program, we have conducted a rather formal evaluation process and an informal one. The formal was conducted by using some mathematical documents from the AMS. The quality of the transcription of these documents was evaluated by engaging two visually impaired participants who we gave them the transcribed documents in Braille Nemeth, and they translated these documents back into mathematics. They actually and we compared these back translations, and the result was very high. It was 98% inter-rater agreement. Also, we consider as very important the informal evaluation, in which has to do with the generation of learning material and the usage of this material by the blind student that I mentioned before as study material. So she used these books and notes in order to study, and in this year, in 2021, she graduated on time from the University of Athens, and now she is pursuing graduate studies in mathematics using this program for supporting her study. The program has of course its limitations, and we aspire for future work on it. There is a limited support for macros. It is not a full tech engine. There is no support for macro expansion, for tech macro expansion mechanism, etc. The design of the initial design of the program was, I might say, more pragmatic. We had to quickly come up with a tool to generate notes in Braille in order to help the student study for her next semester examinations. So we applied some, I have to say, easy solutions in some parts. So it's not a full tech engine, but we behind this system, although all expressions are parsed and generated in the sense that I presented before. So we plan a full re-implementation of the system in order to support full macro expansion and all the capabilities of the tech and LaTeX language. Also, there is a minor problem with the tool. The tool fails to discriminate among symbols, among the symbols period and decimal point. This dot is not properly recognized by the system in some circumstances, and also the support for images is rather limited, and we are working on ways to give a more strong support for image generation for mathematics, for tactile images for the blind. We would like to help Mrs. Olga Maleza, who is a teacher, a science teacher, who has worked for years with the blind student, and she has helped her very much during her studies. But also she has helped us a lot in the development of this tool. And also would like to thank the University of the Generations unit for their grant in this particular project. It was partially supported by this. The project was partly supported by this grant. Well, thank you very much for your attention. I don't know if there are any questions.
I'd like, sorry, can you hear me? Yeah, I'd like to thank you, Andreas, and Antonis and Olga for the work on this in your presentation, which I found very interesting, and I particularly enjoyed the insight I got from Nemeth Braille from that. And congratulations to your student who was your first user. I think that must have been a great satisfaction to you. I wonder if you'd be available for conversation about this afterwards when we both got time. I think we're going to be busy this weekend, but in the coming period.
Of course, we would be glad to.
Thank you very much.
Thank you.
Pleasure.
There's another question that was just asked on the chat. Can you see it, or should I read it out? By Alexei Kolesnikov.
Okay,
Antonis?
yes, I think that, okay, the question is how closely we follow the Nemeth manual. Okay, there are cases that the Nemeth manual has more than one representations. We choose the easiest, and also sometimes there are problems with tech. For example, we do our best, but for example, the problem that Andreas mentioned, like the discrimination between the period and the decimal point. There is no discrimination in tech for these two symbols. It is the same character. So we had problems with this, but in the Nemeth representations, these characters have different representations. So we start from tech that does not discriminate them. And when you go to Nemeth, you have to discriminate. And this is not always simple to do. But we do try our best to follow the Nemeth manual. I think, okay, I would say the following. The student graduated using this tool. So she was for years studied and experienced user of Nemeth. So as a mathematician, I would say that this is kind of proof that the system works. It may have some quirks at some points with Nemeth, but if it does, the students can easily adapt. But I would say that we do follow the Nemeth manual as closely as possible. This is my answer.
Well,
about the numbers, no, the numbers get numbers indicators always for the moment. This is, yes, I know this issue, but as Andreas said, we were in a hurry to support the student, and we thought that, for example, this is a point of difference with Nemeth manual. The numbers 2 and 3 in the example should not get a number indicator, but if they do get a number indicator, there is no confusion. So for the moment, they do get a number indication. It just makes the expression a bit bigger, but the problem to give a precise representation of the math, I think it is achieved.
During the engineering of the software, we will look into this subtleties in the more detail. But as Antonis said, since we were in a hurry, we were a bit pragmatic in our approach. So yes, this. Anyway, thank you, Jonathan. We will look into this document that you point us. Anyway.
No, the pretext. Yes, I should make a comment about pretext. The pretext has the following difficulty. You need to have the source written in a certain way, and in a real world, you go to a math department, and the professor has already notes, and you know it is very common inside the LaTeX document of a professor in the university to see tech code which does not follow LaTeX. Okay, there are many structures that are there even from the original tech system, and the professor doesn't care. The LaTeX understands and produces his PDF. So the pretext has this problem. You have to adjust the source to a certain format in order to work. But we need to go directly from a LaTeX document to Braille without doing modifications or serious modifications to the source code. And that's why pretext was not an option. So if you have a book 500 pages and you have to re-edit the full source, it's not an easy thing to do and no one wants to do it. Anything else, Arthur?
No, I just was going to ask if there was any more question. Well, thank you very much. That was very interesting and a very good introduction to that session. And Antonis, I'm very glad to meet you almost in person for once, because I did a very long time ago really enjoy your book about multilingual typesetting with LaTeX and Omega.
Thank you very much.
I think that was from 2004.
Yes, yes, thank you.